and welcome back to A&P with Emily. Today we're going to be going through more of an overview of the cardiovascular system, so looking at its functions and what it does and how it does it. So last lesson we looked at what it's made up of, so we know that we've got the heart, we know we've got the blood vessels, and that includes the veins, the arteries and the capillaries, and we know we've got the blood that runs through them as well. So I want to just quickly look at the functions of the CVS. So obviously its main function, because of the blood and the conduits, so the blood vessels, it's going to be transportation. So it transports oxygen, and obviously with it carbon dioxide and nutrients, even heat and hormones. Okay, and water as well. Transports all of these things around your body and helps keep you in a state of homeostasis. Now homeostasis is essentially a state of steady internal physical and chemical conditions that are sustained and maintained by your living systems, so your organ systems, okay? A good one to know. So in humans we have what's called double circulation, and that just means that the blood passes through the heart twice on each circulation of the body. So we have systemic and pulmonary. Now systemic, let's do the proper thing, circulation. So these are the two circuits that we have. We have systemic and we have pulmonary. So systemic circulation is to anywhere but the lungs, so to the rest of the body. And pulmonary is to the lungs. Now, we know from our terminology lesson that pulmo does mean lungs, so that should be really easy for you guys to link back to or remember. So pulmonary only goes to the lungs or only involves the lungs, and systemic is to the rest of the body. So before we visit the pathway of blood through the heart, I want to just introduce you to these two bits of terminology here. So systemic arterial network and a systemic venous network. I just want to break this down a little bit. So systemic, we know essentially just means around the body. And arterial, now we know arteries carry oxygenated blood. And we know veins carry deoxygenated. And we know that this is still around the body. So when we talk about systemic arterial network, it's blood that's come out of the aorta that's oxygenated and it's going out to the rest of the body to deliver all those nutrients. And then systemic venous network is after it's gone to the lungs and you've had the gaseous exchange take place, and then it's coming out and it's deoxygenated. So that's what systemic venous and systemic arterial network means. So I wanted to go through that before we get on to the next bit. Now I do not want you to panic. This looks scary, it looks complicated, but it isn't. So this is just the pathway of blood through the heart, and we're going to start at the aorta and finish at the aorta. Okay, so we've got the aorta and then we go through the systemic arterial network, okay? And then we hit the capillary beds, and then that will go to the systemic venous network. The blood will come in through the vena cava, so we'll have deoxygenated blood at that point because we've gone through the venous network. So we come in through the vena cava, goes into the right atrium, into the tricuspid, through the tricuspid valve that we spoke about last lesson, and that will contract and we'll get into our right ventricle. Then we'll hit the pulmonary valve, so that semilunar valve that I spoke about on the right hand side, and then we'll hit the pulmonary artery. Now remember, the pulmonary artery is the only artery in your body that carries deoxygenated blood, so make sure to remember that. And then we're going to hit the lungs, and the lungs are going to oxygenate things for us. So it hits the lungs and we go into the pulmonary veins. Now remember, the pulmonary vein is the only vein that carries oxygenated blood, okay? So do these two, definitely important, either side of the lungs. And then the blood will flow through the left atrium, hit that mitral valve, come through the mitral valve and into the left ventricle. That left ventricle, the blood in there will come up through the aortic valve and then the aorta, and then all of this starts all over again. So that's your circulation through your body. That's the blood circulation, that's the way that it goes. I'm going to leave this up for a little bit longer in case you want to have a look. But yeah, just main big things to remember are the pulmonary artery and the pulmonary vein. So this is the only artery that carries deoxygenated, and this is the only vein that carries oxygenated. And these are either side of the lungs. So go in with no oxygen, come out with oxygen. So the last thing that I want to go through today is electrical conduction through the heart. Alright, so I want to look at the SA node, the AV node, and what they do. So excuse my terrible heart drawings. They're not fantastic by any means. So we've got the apex of the heart down here, and we've got the base of the heart up here. So the top and bottom. Now, we know that we've got the atrium up here and the ventricles down here. So we labelled those in our last lesson, alright? And then around about here, we have our SA node, which is our sinoatrial node. And this little node here is sometimes called our pacemaker. So it sets the pace of the heart. It essentially sets the rate of your heartbeat. Okay, and it doesn't require any nervous system stimulation to fire that signal. It fires on its own. We'll take a look at what that's called a bit later. And then down here, before we get to those ventricles, we've got the AV node, which is the atrioventricular node. Now if you notice, you've got AV nodes and you've also got the AV valves that we spoke about, so the tricuspid and the bicuspid. Now if you can try and link those together, they're around about in the same place. Okay, so you'd have like your valves here. So SA node fires, you've got that little pause in electrical signal before it gets to the AV node. Now when this SA node fires, it fires all across the atria, and that causes atrial contraction. Or atrial depolarization. Okay, so that causes atrial contraction. Your atria contract, and then when we get to your AV node down here, that sends that signal down something here, which is a bundle of nerve fibers called bundle of His. Alright, and those bundles, that bundle of His branches into two. Okay, so it ends up being two, and these are our bundle branches. And then when we get to the bottom here, there are fibers called Purkinje fibers. And they send that electrical signal up through the ventricles and up through the heart in general, and that causes ventricular contraction. Or ventricular depolarization. Okay, now we'll look into depolarization and a little bonus lesson that I'm going to do on the weekend for you guys. And we're going to look at ECGs and how electrical conduction of the heart can relate to ECGs. so we can relate them and see what's happening in that ECG and relate it back to electrical conduction so we can understand what's happening properly. So let's recap what we've done today. So we've gone over kind of like an overview of the cardiovascular system, and we've gone over the two circulatory systems that we have. We've established where they go to get oxygenated, what carries what and what carries oxygenated and deoxygenated. We've gone through the systemic arterial and the systemic venous networks, and we've also gone through a little bit of the electrical conduction, which we will touch more on in that little bonus lesson that I'm going to do for you at the weekend. So we'll go into ECGs at that point and hopefully get to start relating some of this back to a clinical environment for you. So yeah, that's about it from me. That's about it from Kenny. He's looking more festive every day. And we'll see you guys next time. Take care. Thank you.